All right, this is Susan Poss again. I'm still in section 10.5 and we're still talking about graphing parabolas. So I'm going to call this 10.5.2 because this is the second video that I wanted to work through with you. So we started out in the previous one looking at the parent, which was p of x equals x squared. We all know how that looked. And then we looked at some that had a plus 3 or minus 4 outside the x squared, that out there on the end of the function. And that gave us a vertical shift. If k was positive, it shifted up k units. If k was negative, it shifted down k units. So now we're looking at some where the numbers that we're going to insert here are going to be inside the squaring part of the function. So you're going to see parentheses, you're going to see a number inside the parentheses with the x, and then you're going to see the squaring function on the outside of the parentheses. So we're going to explore a few of these, and again, just while we explore, I've created a little table out here with some values in it, and I'm going to just plug in those numbers into f of x. The first one I've got is -1. So it looks like when x is -1, y is 4. So when x is 0, y is 1. When x is 1, y is 0. I'm going to have to start writing smaller here. When x is 2, y is 1, and there again you're going to see some symmetry just like we saw in the previous examples that we did. And when x is 3, y is 4. All right, so let me plot a couple of points, all these 5 points here. -1, 4 is right here. 0, 1 is there. 1, 0 is here. 2, 1, aha, you see it turning around there. And 3, 4. So you can begin to see the shape of the parabola. It's pretty clear now. It's opening up, both arrows going out the top. But now you'll notice that the parabola has shifted off the origin. Instead of the vertex or the lowest point being at the origin, now that has shifted to the right. So my axis of symmetry now, remember it always runs through the vertex. So my axis of symmetry, let me put it in here where I'm supposed to put it, is x equals 1. Remember, it's an equation. Vertical lines have form x equals a number. And the vertex now is at 1, 0. So what happened? Well, it looks like when we plugged in this extra -1 inside the squaring part of the function, it took the parabola and shifted it, this time horizontally. Previously, we were looking at shifting vertically. This one shifted horizontally, and you've got to be careful with the sign here because you know this. Notice this is an x minus 1, but the parabola shifted to the right 1 unit. So we'll explore that real quickly with another example down here. And again, you see I've selected some points and some values for x, and I know you don't know how I'm doing that right now, but after you've practiced a little bit and we've talked a little more, I think you'll understand that. So the first value I want to plug in is -8. I'll try to write smaller this time. So when x is negative 8, it looks like y is 4. When x is negative 7, it looks like y is 1. When x is negative 6, y is 0. When x is negative 5, and here's where you start to see the symmetry, y is 1. And the last one, when x is negative 4, y is 4. So let me quickly plot points. Negative 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Looks like negative 8, 4 should be right about there. Negative 7, 1 is here. Negative 6, 0 is there. Negative 5, 1, and that's where you start to see it turn around. And negative 4, 4. So this parabola has shifted horizontally. There was a plus 6 inside the parentheses, and you'll notice that this equation shifted, or excuse me, this graph shifted 6 units to the left. The axis of symmetry now has moved over here to the equation x equals negative 6. And the vertex now, this low point, which again at some point you'll hear me call that the minimum point, or the turning point. There are a lot of different terms for that. So again, you can notice we're getting horizontal shifts on these. So I hope you're seeing the pattern. If you have a plus 6 inside here, what happened? It shifted horizontally 6 units to the left. So here's our summary. We're going to do these really fast. If the h follows a minus sign, the graph is shifted to the right. If the h follows a plus sign, the graph is shifted to the left. Vertex is at h0, vertical line x equals h. So here we go. Quickly, without plotting points now. That's the whole point, is to try not to have to plot quite so many points and to look at them and know what they're going to be doing. So right now we're going from the equation to the picture. Later on, if you continue with your math courses, you'll be going from the picture to the equation, because you'll learn that different shapes fit with different math equations. All right, so there's my parent in green. Let me put the g of x, function g, parentheses x plus 5 quantity squared. This is going to shift horizontally to the left 5 units. So 1, 2, 3, 4, 5. And then you notice how I'm just balancing out just like I would for the parent parabola. Here's the axis of symmetry now. And here's the vertex. So let's get all that information. The vertex is at negative 5, 0, and the axis of symmetry is at x equals negative 5. All right, one more. Real quickly, I'll see if I can leave that one on screen for you. So again, let me quickly sketch in 0, 0, negative 1, 1, 2, 4, negative 2, 4. Here's the parent, the basic starting parabola. And then I'm looking at this h of x, and I'm noticing that there's a -1 inside the parentheses squared, which tells me the parabola is going to shift 1 to the right. So I'm going to go ahead and put in that axis of symmetry here. And there is the function that's labeled h, and we're seeing a horizontal shift 1 to the right.